So, hi dear students, today we are going to have a course on GTQ, which is Made Easy Live we are giving. So, this course will be very important for the students who are preparing for GATE exam. Okay, seriously, who is preparing for GATE exam. And I'm not wasting your time. I'll try to teach some important concepts and very typical concepts where the students will get doubts on that. Such concepts I'm going to develop today. This course will be very important for the students, okay, who want the concept in a good manner. Because I have seen previously in Made Easy, we are giving in Telegram, we are solving the doubts from 1 month onwards. Every day when I'm seeing the doubts from this particular areas, the students are facing trouble. That's why I have been notified and I am creating some topics. According to the topics, I'll try to create the questions and I'll try to give the logic or trick behind that. So that in future, whenever you get this type of questions in GATE exam or a ESE, okay, easily you can get the concepts. Maybe Made Easy students are watching, and maybe my students are watching, or maybe my students are not, some other students are also watching. This concept should be gained for everybody. That is the main intention we are giving the live. Okay. So my name is Adada Raj Kumar. I'm a faculty in Made Easy. So first of all, let us go to the topics. The topics we have is nearly around 9 topics we are going to cover today. They have given a time of 2 hours. Maximum we'll try to cover all the example problems according to the topics. So I'm expecting the topics in the first, we are going to start with op-amp and BJT in feedback loop concept. Mainly most of the students are doing mistakes. Already these questions came in GATE in previous years. Maybe for EC students, electrical or instrumentation, the concept is missing for the students. So today try to understand with some examples. This is one of the beautiful concepts today we are going to understand. The next we have is a precision circuit concept. The next one is a precision is also an important concept, which is based on op-amps with diode logic. I'll take certain example to understand that concept. Coming to the next one is op-amp with a positive and negative feedback at a time. So whenever positive, negative are connected at a time, the student is getting confused whether the positive feedback will dominate or the negative feedback. So today I'm bringing some good technique for you for that. I'll take some good examples to teach you how to tackle this type of questions. Okay, mainly the problem will come on this. So topic number 3 is the highlight for today class. One of the important and logical concept I'll teach you today. And coming to the fourth one, differential amplifier concept in op-amp. I'll take one example for that because differential amplifier is an important concept for the competitive exam. These are the 4 basic concepts we'll cover main issues of op-amps. And coming to the fifth topic we have is oscillator. Oscillators, I'll take some examples for you and we'll cover the oscillator basics. With these 5 concepts we are covering. After that we have topology concept. Topology is one of the important concepts in negative feedback system analysis. I have taken one example to teach you how to understand a topology connections, how to take the sampling, how to take the mixing of the input. We'll try to understand. The next we have 2 interesting topics in GATE level. One is small signal analysis of BJT and one more is small signal analysis of Mosfet. These are very, very interesting topics to learn. I have taken certain examples to understand these concepts for the student level. And coming to the 9th topic, active load concept. Okay, previously 2 days back, one of the student is asking, I'm getting problem in active load concept. Maybe that concept, most of the students have trouble. Let us analyze it and we'll try to finish that concept. Anyway, we got no signal. Just 1 minute. Yeah. Sorry for the interruption. Sorry for the interruption. Okay. Very good evening to everybody. Very nice. I'm seeing all my students. Very good. Thank you for joining to the live class. Let us start the course now. These 9 topics will start one by one. We'll analyze the picturization on each concept. Let us start with the first concept. Topic wise, I developed the concepts. So the first concept we'll see. So topic 1, I've started with some examples now. What is the topic 1? I promised you to teach is op-amp with BJT. Op-amp with BJT in the feedback loop concept. Most of the students, when you see this circuit, we have BJT, we have op-amp. Both we have. Most of the people are getting confused with this loop concept. Try to understand this beautiful concept. Within 2 steps, I'll finish the problem. I'll not take much time to solve any question in analog electronics. With my experience, I'll tell you the tricks how to apply for the concept. Let's see this question. Suppose somebody asks you in exam. Let us understand. By seeing this positive feedback, it is looking like a positive feedback. Okay, the question is asking, estimate the type of feedback for this circuit. Not only feedback, is asking calculate the Vx at the output of the op-amp. This is the question for you. Please try to concentrate on the question. So most of the students, they will say that this is a positive feedback. Directly they will see that and they'll try to confirm. In the exam point of view, they'll write positive feedback. Then I think it will become mistake in your exam. Why? Because here, not only op-amp, we have BJT also. Try to understand BJT is also having phase shift. Whenever we use common emitter mode, it gives 180 degrees phase shift. If it is connected like a common collector configuration, it will give 0 degrees. So there is a phase shift analysis for a BJT. You should count the BJT in the loop. Most of the students are not doing that. Just seeing this feedback, they are telling it's a positive feedback. That is wrong. Let us understand it. First, my concept here is, without knowing BJT, whether it is on or off, how can you test the feedback? So the first rule number 1 for this question, we should not say the feedback. The first step 1, we have to identify the transistor BJT is on or off. That is the first position. In this type of problems, it can be cut off or it can be active. This type of circuits cannot go to saturation. There are 2 possibilities. It can be cut off or it can be active. Let us understand how to do that step 1 process. Okay, see how I'm going to analyze this problem. Step 1. Just step 1 I'm doing. Step 1. In the step 1, if you see, we have to assume the transistor is off because I don't know whether it is on or off. So let us assume it. Assume Q is off. So our transistor, I give the name as Q. Q is off. If the Q is off, the diagram looks like this. This is 1K. This is 5 volts. We have the op-amp minus plus, sorry. We have here plus, minus. Minus is 2 volts. And make it as open like this. This is 100 ohms. So do it like this. Your transistor is in open circuit mode. Now let us understand, there is a base to emitter one diode is there. If such diode is on, we can say it is in active region. If such diode is off, we can say it is in cutoff. So there is a diode we'll keep here, which is base to emitter diode. Main interest is to find out that diode position, whether it's on or off. Whenever you made this transistor in open condition, the op-amp will work in open loop system. Everybody knows that whenever the op-amp is under open loop, it will work like a comparator. I'm expecting it is working like a comparator, open loop comparator. So I don't have any current flow here. You can see from 5 volts, the current cannot go this side because op-amp is having very high input impedance, correct? Current is not going. If current is not going, this 5 volts will come here because across 1K there is no drop. The same 5 volts we can take here. So at the non-inverting side we have plus 5 and the inverting side we have plus 2. So you can have the difference is positive or negative. If you see the difference is coming positive value. because positive side we have higher potential, negative side we have lower potential. When VD is compared as positive, the output of the op amp will give as answer plus V saturation. So like this easily you can find out the output of the op amp in open loop system. Okay. So whenever I know this answer, the diode status is very easy to confirm. When anode side is connected to plus saturation, the diode will be in on condition. If suppose by chance this answer came minus V saturation, which is connected to the diode anode side, it will become cut off. Now it is in forward bias. When diode is in forward bias, I can say that this diode is on for this case. So Q is inactive we got. Q is inactive. The transistor I assumed as off, but the transistor is telling I am in on condition. So now this is the first step a student should do initially. Without doing this, directly if you tell the feedback, that is a wrong thing in the analysis. So first step is over. It's very clear. The transistor is in active region. The transistor is in active region. Thank you very much. Good evening, students. So the transistor Q is in active region we got. Whenever the transistor is in active region, that means we can have a closed loop. If the transistor by chance, if it comes as cut off, the transistor will be open. At that time, no need of telling any feedback because the loop is open. But when the transistor is on, we have to confirm the feedback. How to confirm it is the concept. Let us see how I'll confirm it. So let us make this screen small so that I can complete here only the task. Okay, step 1 is completed. Now coming to the step 2, finding the feedback, how I'll do it. Step 2. In step 2, how to find out the feedback position. It's a very easy step, finding the feedback position. First you confirm that the transistor what you connected is which type of configuration. Please try to understand. The input is going to the base. The input is going to the base and it came from the output of op amp. Base is the input and the output we are taking feedback side, output is collector. So when the base is input, output is collector, this is working under common emitter mode. It is on. Everybody knows common emitter will give 180 degrees phase shift. Let us write a box for that. Common emitter is working here, which can give 180 degrees phase shift. So it is getting fed back like this with an op amp and it is getting closed. This is the way how you close the system. Op amp, whatever you have taken, where the feedback is going, you have to see. It is going to not inverting side, it is going to non-inverting. So whenever it goes to non-inverting, can I say that it has a 0 degrees phase? This is the way how you can write the loop concept, phase concept. The transistor is working in active and it's a common emitter mode for us. So it has 180 degrees phase shift. A non-inverting feedback will have 0 degrees. So ultimately, finally, how I'll test which type of feedback it is. Positive or negative means I'll find out the loop phase how much. Feedback loop phase how much I'll find out. The total phase is coming by two systems. One is BJT and one is op amp. The total phase will be 180 degrees plus 0 degrees, which is equals to 180 degrees. By seeing this concept, I can understand the system is not operating under positive feedback, it is operating under negative feedback. This is the points you should not miss in the concepts. Okay, most of the time the mistake is happening because the steps you are not understanding clearly. So finally, I can estimate that this feedback may look as positive side, but it is working under negative feedback. The only reason for that is BJT is giving 180 degrees phase shift. Okay, it's very clear. So whenever 180 degrees phase shift comes, the system is under negative feedback. The system is not in positive feedback, the system is under negative feedback is working now. Whenever the system is under negative feedback, we can apply virtual short or virtual ground concept. So easily you can apply now. First concept is negative feedback, the system. and V plus equal to V minus we can apply to solve this problem. Okay, so whenever I apply V plus equal to V minus, I think the same diagram we have to draw it. This is 1K, this is 5 volts. We have op amp plus minus. Minus is connected to 2 volts, which is connected to a transistor in common emitter mode with 100 ohms. This is ground. Again, I repeated to solve what is Vx. He's asking what is Vx in the problem. So he want to know this answer, Vx. But I know that this diode is on, so we can take 0.7 volts because in the data he has given, base emitter voltage is 0.7. Already I confirmed that the transistor is in on condition. So it is 0.7. Only thing is, if I know this emitter voltage, I can find out the Vx value of the op amp output is Vx. So to find out this voltage, we'll apply the virtual short theory concept where we can take 2 volts here. V minus and V plus are same for negative feedback systems. Okay, so with this, these 2 volts will come here such that we can find out the IC current. IC current is coming 5 minus 2 divided by 1K. The current is coming to be 3 milliamperes. So the current IC is nothing but 3 milliamps. Okay, if IC current is 3 milliamps, the beta value he said 200 in the problem. You should use some logics in the GATE exams. Blindly don't do the questions. A beta who said 100 above any value, we consider as very high value in analog electronics. As beta is very high, we can say that the IB current is approximately equal to 0. If IB current is approximately equal to 0, IC is equal to IE we can take. Okay, that provision you have. So because of that, this IC cannot go this side current, so it will be directly equal to IE current, which is 3 milliamps. So the same current you can get. IC is equal to IE current. If these two currents are same, emitter voltage we can find out. The emitter voltage is IE times into 100 ohms, which is 3 milliamperes into 100 ohms, which is coming to be 0.3 volts. So the emitter voltage we are getting around 0.3 volts. Then finding Vx is not an impossible thing. By using KVL we can solve it. What is Vx here? Vx is VBE plus VE will give the answer for you. This is the way how to solve this type of questions. The emitter voltage is 0.7 and VE voltage is 0.3 volts. Finally the answer is 1 volt. So this is the way how this type of questions can be solved. I am expecting, yeah, thank you very much. Great to see all of you students. So I am expecting this model is very important where the student should understand. I have seen most of the students, this type of questions when they see, they say positive feedback. But I think by seeing this method, you can understand how much comfortable these problems we can do it. Now I'll come to an example 2 to complete this topic 1, which is a GATE question given already in 2018, where the GATE examiner has given the solution itself wrong at the time in 2018. Okay, GATE key itself wrong. After 3 days, he changed the answer. That means in this type of questions, maybe, okay, as teachers, we also will get confused. But if you do step by step like this, you will not get any confusion in the problem. Okay, let's see, we'll move to the next question, which is already a GATE question. We have taken an example to verify that circuit, how it is going to operate. Let's see the second question. Okay. Yeah. Yeah, Vinith. The op amp will work as a buffer, correct? Yeah, it's a doubtful question, Verma. Great. So now we'll move to the next question, which will complete my first topic today. So you can see the example number 2 one time. This is a second example for the first topic. Same question. It came for instrumentation. I have been remembered because at that time the key came wrong in the first day. After 3 days he changed it. That's why most probably I remember this question well. You can see this GATE 2018 instrumentation, same type of question, op-amp with BJT problem. Let us identify what is the correct answer for this question. Okay, you can see in this problem the beta he has not given 200, he has given only 20. At that time, be careful, we cannot take IE is equal to IC. IE will become IB plus IC we have to take, because when beta crosses above 100, I have a privilege to take that value in analog electronics. But if beta is below 100, we cannot take like that, because it comes under low beta value. We have to find out IE is equal to IB plus IC. He's asking this current which is flowing to the ZL. He's asking how much current will flow. You know the trick now? You know the trick? By seeing this negative feedback, we should not say that is negative feedback and start the problem. It is dangerous. First very important task is step 1. The transistor is on or off. If the transistor gets on, then only we have to check the feedback. So let us start with the step 1. The same method I'll apply. Step 1. All these questions, do it like this, my friends. You'll never get a problem in the concept. Okay? You'll never get a problem. Step 1. The transistor is cut off. Okay? The transistor is cut off, we'll take. Assume Q is cut off. So we'll see that the transistor is in cutoff position. Okay, then this diagram looks like this. This is 10.5K. This is 5 volts. This is open circuit. Okay, we have an op amp like this. Sorry, we have an op amp. Negative, positive. Positive side we have 2 volts. Negative side is connected to this point. And finally, we have some ZL. Okay, there is a diode here, which is base to emitter connected, which is very valuable diode to understand whether the switch is on or off. We can identify very easily. Now the system is under open loop because the diode is assumed as off there. Okay, then I use the same knowledge. This current will be 0 to the op amp, because the op amp, the current will not be allowed to the op amp because of high input impedance. Can I expect this 5 will come here? This is 5 volts. Now you can see the comparator is working. Negative side it is 5, positive side it is 2 in this case. Negative is dominating the positive in this case. So I think here the difference VD is coming to be negative. The difference is coming negative here, correct? Okay, the difference is coming negative here. When the difference comes negative, the output of the op amp will be minus V saturation in the problem. The output of the op amp is minus V sat, but this minus V sat is connected to the anode of your diode. When it is connected to the anode of the diode will be cut off. Maybe that means that the previous question the transistor is on, present question the transistor is off. According to the design, we have to understand whether the transistor will be on or off easily by the comparator knowledge. So can I say that minus V saturation will make the diode to be cut off, will make the diode to be off. So we can say that the Q is in cutoff. So finally I justified the transistor is in cutoff position. When the transistor itself in cutoff position, I think whatever the assumption I have done is correct. So no need of going to step 2. In step 2, when you have to go means when the transistor gets on. At that time to notify which type of feedback system it is. But in this case, step 1 itself completed my task where the transistor became off. So it's an open loop system. Therefore, if transistor gets off, can I say that the current here, which is IL or I0, will be 0? Because the BJT is in cutoff position, there will be no emitter current. Because IB is 0. I will be 0 automatically. This is the actual procedure. He is given this solution by the GATE key after 3 days. But some students, when they are asking this doubt in Telegram, they have been constrained to 300 microamps is the answer. Because in the first case, okay, the GATE has released the answer as 300 microamps. So most of the students are fixed to this answer. That is a blended mistake, my friend. 300 microamps is not the correct answer. It will be 0 microamps is the correct answer. What is the reason why 300 microamps is coming means most of the students, how they'll do the mistake here is by seeing this negative, they'll feel that it's a negative feedback. If you feel this is a negative feedback, this 2 will come here and you will find out some here IC current. You'll get some quantity, some around 2.83 milliamps, some current is coming. Then IB current you will find, then IE current will find automatically we are getting 300 microamps of current. That is blender mistake for this question. Only first step number 1, please always remember the transistor position you have to check. If the transistor itself is not conducting, how can you tell the feedback for the circuit? Feedback you can explain only when the transistor gets on. That is very important task for this type of questions. I'm expecting these 2 examples. So this 300 microamps is the wrong answer. After 3 days, the answer has changed to 0 microamps by the GATE exam. So please try to understand this problem, okay, and don't do the mistake, the silly mistakes in this type of questions. If directly feedback is connected to the op-amp, I can straightforward tell negative or positive feedback. But when BJT comes into picture, we cannot tell like that. You should take care about that, okay. I'm expecting this is the story about my first topic. Is clear? I'm expecting all the students can expect the first concept is clear. Let us start for the next issue now. That is topic number 2 will start now. Okay. Yeah, Verma, you can say feedback is positive, but feedback you can say positive or negative when the transistor gets on. Here by confirmation it became off, so no need of telling any feedback for this. Okay. Yes, sir, clear. Great. So let us start my second concept now. First concept is very interesting to learn. Second issue I'm going to see. What is the next issue? Try to see. Okay, friends, this is a precision type of circuits. Most of the students, these are all valuable topics in analog electronics. I have taken only one example, that is enough to tell you the procedure how to do this type of questions. See here, estimate the transfer characteristics for the given precision circuits. Precision is nothing but accurate. Okay, rectifiers we can do with the precision op-amps. So can you see that in this type of questions we have seen diodes will be there, op-amps will be there, all these things. One thing you keep logic in analog electronics, whenever op-amp is connected to anything, any device like BJT or MOSFET or maybe a diode, the first very important logic is make the devices like BJT, diodes or MOSFET, make it cut off first. Then what will happen is the story now. So the first step is very common for everything, this type of problems. Step 1, what is my story here is, assume D1 and D2, I'll make it as off. Like our previous class, BJT is off. Now diodes are off. Whenever the diodes is off here, this circuit, how it looks for you. That is a very interesting point to learn. This circuit automatically will change like this, a simple circuit. Minus plus, plus is grounded. This is your input and this is your output. If you correctly observe, the circuit will be looking like this. So how, sir, means this is open. This is open. You leave this 2 feedback loops. And only resistor is connecting to the inverting side. No current will go, so there is no drop across the resistor. So I can expect that this diagram looks like this simply. So this is called a precision technique, which will look like a ZCD called zero crossing detector. It's like a comparator, I can say. It looks like a ZCD, which most of the students have learned. First application of nonlinear analysis. ZCD is very simple topic. Comparator, we have to do it. So in place of writing this output, we will indicate here some voltage as op-amp output as VA. We'll take VA as an op-amp output, and here we'll change it to VA. That will decide the diode position today. So let us write the comparator answers. If V input is, first step, if input is suppose greater than 0, I have taken. My input is in the positive side, which is greater than 0. If you take the negative is dominating the positive here, so VD becomes negative here, because the negative is dominating the positive value. Negative is dominating the positive value. When negative dominates the positive value, your VA value will become minus V saturation. Okay, VA, op-amp output will become minus V saturation. That is enough to tell you this two diode status in the problem. Okay, if you write here, suppose minus V saturation, you got. It's very easy to confirm which diode is on, which diode is off. One negative sign is connecting to the anode of the diode. One negative sign is connecting to the cathode of the diode. Cathode always connecting to the negative, it will become forward bias. Anode connecting, it will become reverse bias. That means D1 is showing interest to get on. In this case, D2 is getting off. So in the first case, we can say D1 is getting on, D2 is getting off. This is the step 1 analysis. Like that, first you understand the status of the diodes by using op-amp output. Okay, it's very clear, I'm expecting. So write this model according to the concept. So your model looks like this. This is minus, plus is grounded. We have a resistor here, R. This is Vi. And we have a resistor R here. And this is your output. This is short circuit. So this is the loop we have. Because diode is on here, here diode is not on. Remove this loop, connect this loop. Can you see that this circuit is looking like a negative feedback amplifier? Okay, it's a negative feedback amplifier. And not only that, it's a phase shifter, we can say, because equal resistors we have. So the gain formula is minus RF by R1 into input. So the answer will be minus R by R times of input, which is a non-inverting input, non-inverting gain, which is giving us minus VIN as an output. So in positive half cycle, I understood the transfer characteristics of the system is like this. If I go to the negative half cycle, what will happen? If the same procedure, if I apply for negative half cycle, that is input is less than 0. If my input is less than 0, I think the positive is dominating the negative now. So therefore, your VD becomes positive and the output of the op-amp will become plus V saturation. So now VA becomes plus V saturation. So in place of this, we'll check with plus V saturation. D2 anode is connected to plus, so D2 is getting on in this case. D1 is getting off because it's connected to the cathode as positive, so it can be off. So we can say that D1 gets off, D2 gets on in this case. So D1 is off and D2 is on. Okay. Okay. So D1 gets off and D2 gets on. Then this model, if you draw it, redraw it, it looks like this. This is R, this is the input. We have the op-amp, minus plus, plus is grounded. We have a resistor and it's a short circuit here. And we are taking the output. This is resistor again. If you see that this diagram is also looking as a negative feedback system with having equal resistors, which will work like a phase shifter. This diagram is looking same. So here the answer will be again minus VIN. So have you seen the peculiarity of this circuit? It is working on both sides. In positive half cycle also it is working, negative half cycle also it is working. So in the exam point of view, if this type of questions are coming, you have to enjoy it. You should not feel tough on the problems because it's a very simple concept. Just using comparator, I am solving the questions. So with this, what is the transfer characteristics is asking? So what is the answer for this is? Can you feel that the answer should be like this? This is your input, this is your output, correct? The first output is equal to input. In positive half cycle, you have to write like this, 45 degrees line. But he said output is minus VIN. So it will get reverse output like this. This is output equal to minus VN. It has to come in first quadrant, but it's coming in fourth quadrant because it is inversion we are getting. In the negative half cycle, output is equal to input means third quadrant will get. But answer came it as a phase shift output. So the answer will be like this. This is output equal to minus VN. Can you see the transfer characteristic for this circuit? Maybe tomorrow the examiner may change this diode positions. He can play the game whatever he want. But we should have a good concept. That concept will make the student easily can do the problems. See, hardly 1 or 2 steps I am completing the questions. So this basics you have to keep in mind when you're doing this type of precision circuit analysis. So we don't need more number of examples. This example who understood, you do every question like this. You'll get the concept behind this. Okay. So I'm expecting, okay. So let us move to the next concept. This completes my second topic, precision circuit concept we call this as. Now I'm coming to very interesting, I think it's a very tough concept where most of the students are feeling difficult. Now I'm going to start the topic, which will be the highlight for this today lecture. Okay, that will be the highlight for the today lecture. Let's see what is that concept. See, this is the concept which is the highlight for this today lecture, where most of the people are getting confused with these techniques. So I have taken some good number of examples to understand this type of problems today class. So please concentrate. It's a very valuable topic I'm teaching. So correctly see this diagram. It is having positive feedback and negative feedback at a time. Both feedbacks we have. If it is only positive feedback, simply I know this is a positive feedback directly. If it is simply negative feedback, I can say negative feedback. That is no, there is no need of talent for that. But if both are connected, then only the mind is getting disturbed. Which feedback it is. Then they have given some method for this. I think this method I have not explained in my class also for my students. Today I want to take that privilege to give some new technique for it. I have given a general technique to solve this type of questions, but today I am giving a new method which can clear off your doubts in this type of system analysis. That's why I have written this as concept. First concept I'll develop, and any number of questions I can solve very easily, okay, with a fraction of seconds. We can get the answers. Let us see the procedure. Let us see the procedure for this problem. How I'll try to start the concept. There are 2 steps I follow to resolve this problem. Okay. What is that steps you can see? Step number 1, point number 1. External input source should be grounded. This is the first step you have to do. Rule number 1. When you want to test which feedback in the circuit, the first rule I applied is external input, please make it ground. What is the reason behind this also I'll tell you. Why I have made input ground means, if this is grounded, I can find out from output how much is going feedback at the negative side, how much the feedback is going to the positive side. If positive side voltage is dominating the negative side voltage, I'll say that it's a positive feedback. If a negative side voltage is dominating the positive side, I can say it's a negative feedback. Like that, we can check the feedback which is dominating. That is a simple trick I am applying. So let us apply it. External source here is VIN should be 0. So don't bother the inputs. Anywhere he has given input, you can leave it. Suppose this input is given here in somewhere, you can make it ground here. So the first job is ground here to do it. Rule number 1 is very simple. Okay, rule number 1 is rule number 1 is this one. VN should be equal to 0. That is the first one. What is the second point here is disconnect the op-amp output and increase the V0 value by some del V. See, the next step what I have done is just to disconnect the output from the op-amp and make this output assume that it is rising by some small voltage del V. Okay, then if you can do it like this, okay, point number 3, last step. The final step here is calculate V minus and V plus in the circuit by voltage division rule. So these are the simple 3 steps you can apply for any type of questions based on positive and negative feedback. Easily I can identify what type of feedback system it is. The first rule is VN should be ground. The second rule is break the output so that the output will go commonly for both the systems. We'll find out V minus and V plus by using voltage division. That means the circuit looks like this. This is op amp, minus plus, break the output here. This is the breaking the output. Assume that that output is increasing by some positive voltage, slightly it is increasing by some voltage, assuming that. And connect the feedback system now. This is RB and this is RA, and make the input source ground. Don't bother the input, make it ground. On the other side we have the feedback. This is RD and this is your RC. So this is the way you have to do every question. If you can do like this, we can find out some V minus here. We can find some V plus. Using some voltage division by I said means, if you break this lobe, it looks like a division circuits on both sides. Easily you can find out what is V minus and V plus by using voltage division rule. According to this problem, your V minus will be del V into, we assumed that some output is increasing by del V, into RA by RA plus RB. Like this you can solve the V minus by seeing this divider network. And the same V plus also we can solve. It is a del V into this resistance division RC by RC plus RD. Like this you can solve the answers. I have not given the data here. In the next example problems we'll solve it and see that if V minus is coming greater than V plus, we can say it is negative feedback. So the rules we can write here is, I'll write the rules here. Just I'm making minimize this screen to write the rules. Yeah. What are the rules we have to follow here is, first point, the rule number 1, if suppose V plus is coming greater than V minus, it is a positive feedback, we can say. Means here positive feedback will get dominating your negative feedback, we can say. Okay? Positive feedback will dominate the negative feedback. In the second case, if you see V plus is less than V minus, if you get, if the non-inverting is coming less than inverting side, we can say it is a negative feedback. It's a negative feedback. Sometimes peculiarity will come, V plus is equal to V minus. Like this also we can design the circuit. Sometimes non-inverting side, inverting side, both will get the equal position. At that time you should not comment anything. Okay, both feedback gains are same, you can say. Feedback gains are same. So that means no feedback will dominate in this case. Both have equal feedback in the last case. So to understand this type of 3 situations, okay, I have taken some examples, good examples to understand the problems. Nearly 5 examples I have taken. Each example I solve below 1 minute, one by one, and just verify it, which feedback it is, so that in future when you are doing these questions, you never get doubt in the type of questions when you do this type of analysis. So let us apply Varma, it is not V plus del V, okay, only del V you have to take. When you are doing voltage division rule, only take the output as indicated as del V, not V plus del V, okay. Please try to understand it. Now this method will apply it. This method I'm going to apply for certain examples. Let's see how I'll finish below 1 minute. I'll solve the problems very quickly. This is the first question here. Carefully observe it. This is the first question example. Now I have to check it and I have to tell what type of feedback it is. What is the trick I have said is, this has to be ground. Your input should be grounded, first point, and the output should be break, and assume that the output is slightly rising by del V, and find out the V plus and V minus. The trick is very simple. Let us finish off. This is your op amp, this minus plus, okay, break it and take the output as some slight V is increasing, del V difference, and this is connected to feedback. This is connected to feedback, and this is connected, this is 1K, this is 1K, this is 1K, and this is ground. The model you have to represent like this now. Can you tell what type of feedback it is now? Can you do it and check that whether this feedback is a positive feedback or a negative feedback? Can you give the reply in the chat, my friends? So dear students, can you give a reply for this question? So I think we'll find out this V minus here, and this is V plus. V minus straightforward, it is 0 because the input is directly connected to the negative side. It become V minus is 0. Okay. Some person has said positive feedback. Some Swati Gupta is telling negative feedback. 465 AR ranker is telling positive feedback. Great. Some are telling positive, some are telling negative. Let us verify it, what type of feedback it is. So this V minus is 0. What is V plus here is? It is del V into 1K by 2K. It is coming to be del V by 2. So V minus we got 0, V plus we got a positive quantity. That makes me to tell you V plus is greater than V minus. It's a very simple. So finally this system is not a negative feedback, it's a positive feedback. Okay. I think most of the students have given positive feedback. Great. Great to see most of the students. Swati Gupta, again you change it to positive feedback. Nice. Great. Now I think you should not have any doubt based on this concept. And not only that, we can use common sense for this question. Without doing this testing also, easily I can tell it's a positive feedback. What is the trick behind this is, can you see in the exam point of view, if anybody connect negative directly to the VIN, please understand this small trick. If you directly connect negative to the VIN, that means you are taking some feedback from the output, is not going to the input because you have fixed it to VIN. That common sense is enough to tell you it's a positive feedback, because from output we are getting some feedback here, but it's not coming here because negative side we have fixed it with some voltage. When negative side, if you fix with a constant voltage, you're taking some feedback, but it's not coming to the input side. That common sense is also enough for this question actually, without doing like this. Okay. So seeing the problem, we can tell it's a positive feedback. It's a positive feedback. I think everybody is agreeing with me. Great. Everybody is agreeing with me that it's a positive feedback. Nice. We'll take one more example. We'll move to the next example. Can you feel that this circuit, without telling first, can you finish off? Only 30 seconds you have the time. Other 30 seconds I'll utilize to find out the answer. This circuit, by saying, can you confirm what type of feedback it is? Try to confirm it. This circuit is what type of feedback? Again, this 465 AR is telling negative feedback. Great. This person is giving good answers. Very good. Jyoti is also giving negative feedback. Okay. Everybody is giving Swati Gupta, Rinku, Verma. Very good. Nice. You understood the trick, I think. This problem also is not required to solve it. By saying directly, we can tell the answer. What is the trick here is, you have taken some feedback to the positive side here. You're taking some output feedback to the positive side, but somebody has connected a voltage source there. Whenever you connected some voltage source is fixed at the positive side, the feedback what is coming is not going to the positive side. So finally, this feedback is not working. This feedback is not working. So only this feedback is working. From here to here, we're getting some voltage. So this circuit also not required to test. So this common sense you have to keep in mind. So this is working under negative feedback. I have taken some good examples to understand variety of situations. It is under negative feedback. Most of the students have been verified. This is a negative feedback is a good answer. Great. Let's see. I'll make it somewhat typical now, the problem. If you identify that, it's a good thing. Okay. Let's see one more. Okay. Let's see one more. Example number 3. Can you see this circuit? Okay. 30 seconds for you again. Can you find out what type of feedback it is? Try to think what type of feedback this circuit. Giving just 30 seconds. You take some rough paper, keep it with you in front of you. Take rough analysis and finish off. Don't take more than 30 seconds. I've given a beautiful trick for it. Abhijit, positive feedback they are telling. Shubham Singh, negative feedback. Ram, positive. Ravi Kumar, negative. Puneet, positive. Positive, negative, negative, positive. We are getting all the feedbacks, positive, negative. Every time the students, whenever we ask the questions, they'll give all the possibilities of the answers. These IIT professors also, when they are preparing the GATE paper, they'll try to check the question with the IIT students. Some students will give correct answer, some students will give wrong answer. Their trapping for the student is they'll keep wrong answers first, so that the student will attract to that answers. Okay, mistakes they'll do well. So you got positive, you got negative. As a student, as a teacher, I'll finish off within 30 seconds. You can see the answer. You can see where the mistake you have done. This is negative, positive, same procedure I'm applying. This is a break of the output, where you can take this del V, and we connect this to 1K and this to 2K, and we have a feedback here 1K, and we have one more 1K to ground. Your input should be ground. Okay, just find out what is V minus here and what is V plus here. V minus is nothing but del V into 1K by 2K, which is coming to be del V by 2. So V minus we are getting del V by 2. But V plus, if you want to find out the answer, we are getting del V into 2K by 3K. So the answer is del V into 2 by 3. So can you see the situation how I prepared is V plus is coming more than V minus, because 1 by 2, 2 by 3, if you say 2 by 3 is more than 1 by 2. So finally, yeah. Okay. Yeah. So the answer will be V plus is coming greater than V minus in this question. So we can say this question, whenever they ask you, okay, till now they have not asked this type of situation. Most of the times they are asking negative feedback, but be careful. First checking is very important. Now positive is dominating the negative here. When positive dominates the negative, we can say it is a positive feedback. It's a positive feedback. If somebody by chance, if they ask you what is the output for this, we should not start doing the problem, because a common sense is required. Whenever the system works under positive feedback, it's not required to solve anything. The output will become plus or minus V saturation. Simply tell the saturation answer. If it is a negative feedback, then we'll apply the virtual ground concept and we'll solve the question. If it is a positive feedback, don't solve anything. Output you can say plus saturation or minus saturation. So I'm expecting this is good. Okay. Verma, what is the logic behind your trick? There is a simple logic, nothing is there. Here when you break the output, I have given some common voltage. For the negative feedback side, for the positive feedback side, I have given a common output, such that negative side is dominating the feedback or a positive side is dominating. I am just verifying it. Taking a common output voltage, assuming that the del V is increasing slightly. And we started the testing for that, nothing more than that. Okay, it's a very simple trick. Okay, this trick you have to understand very well. A beautiful trick. Anyway, if you understand this concept, the next example is easy. You can do it yourself. Take this example and please check it. What type of feedback it is? Example number 4. I'm giving you very good examples to understand the concepts. Okay, immediately apply the trick. Yeah, positive feedback is dominating the negative feedback. Previous problem, positive feedback is dominating the negative feedback. This question you can simply verify it. What is the answer? First, roughly I'll draw the diagram. This is minus, this plus. Break the output, which is del V, and take some feedback, which is coming 1K, and we have 1K. This is ground. And positive side we have 2K and we have 1K to ground. This is the situation. Simply find out V minus and V plus and finish up what type of feedback system it is. This is V minus and this is V plus. V minus is del V into 1K by 2K. The answer is del V by 2. The answer is del V by 2. What about V plus? voltage, if you apply, it is del V into 1K by 3K, which is coming to be del V by 3. Like this, I have been designed the circuit actually. In this case, how I set the resistors here, this is very important. Setting the resistors are important. I think this comes under the category of negative feedback. Examiner, how they'll give, I don't know. You have to check it and properly how to do it. Sometimes inverting, I'll make it more than non-inverting. So non-inverting, I'll make more than the inverting. It's not a very big task to test the concept. Now in this case, V minus is coming greater than V plus. 1 by 2 is more than 1 by 3. So V minus is coming greater than V plus. So most of the students are giving negative feedback. That's a great thing. Good. This is a negative feedback system. Whenever there is a negative feedback, your output, we cannot say plus or minus V saturation. This is a wrong answer. Only that privilege I have when it's a positive feedback. When it's a negative feedback, we'll undergo with the virtual concept and finish the answer. We'll go for V plus is equal to V minus concept and we'll finish these problems. Already in Made Easy workbook, this type of questions we have done it nicely. Our students knows these questions very well, but the trick I have not explained. This trick now I got a chance, a privilege to explain for the students by seeing their doubts. Okay, so I'm expecting who is watching this video will be getting benefited with these tricks. Okay, I'm expecting confidence is coming for you. The last final example, which will complete my task on these examples. Let us go with one more example. This is the final task. You see this concept. What type of feedback, if somebody asks you the question, can you expect what type of feedback it is? The last example I have created. In this example, I have seen that above resistors, below resistors, I made balance. When both sides, we have the 1K, 1K, below also 1K, 1K, what the system analysis is? I think if you take the design, this is minus, this plus, break the output with some del V. And take here 1K and we have 1K. This is ground and we have 1K here and 1K. Perfectly, if you observe, V plus and V minus is showing both same voltages in this problem. Correct? Both are equal, positive and negative feedback. Swati Gupta, perfect. Abhay, great. Tanmay Jyoti, perfect. Chandra, Kishore, Ram. Very nice here. You're all giving good answers. I'm very happy for that. And this 465 AR, V plus equal to V minus. Neither positive nor negative. Abjit, magic. Great. So V minus, we are getting it as del V into 1K by 2K, which is coming del V by 2. And V plus is coming as a del V into 1K by 2K. It is also coming del V by 2. So both sides we are getting same answers. Whenever this question comes, they'll give the options as positive feedback, option A, negative feedback, option B, both feedbacks, okay, both feedbacks at a time, fourth one, okay, no feedback is working. So if you see that in this case, positive, negative are balanced each other. So no feedback is working. So positive feedback is getting balanced with the negative feedback. So equal gains we have. This type of circuit does not have any meaning actually. In applications, I never use this type of concept. That's why when you do this design in piecewise or when you're doing in the problem, you're not getting any big output here. A peculiar answers we'll see. That's why this question is an example for us where we should not use this type of concept. Because when you use a feedback system, we have to get some feedback. It can be negative or it can be positive. But this type of situation, we should not apply in the application point of view. So in the example, when they ask you, you say that both are getting balance, equal gains. Okay, that is the situation we can explain. So I'm expecting Abhishek Dev is asking this trick is not complete in class. Abhishek, in the class I have not explained, but I have given the virtual ground method. But this trick sometimes, whenever I have a privilege to teach, okay, some new points I have to teach, then definitely I'll create a new concept for you to get the tricks. So please try to get now. All the times in analog, there will be no one method. Different methods we can solve it. I have taken a general choice of method is V plus equal to V minus technique there in my classroom. Now this is a new method I am teaching for you. The same thing if I teach, then what is the meaning of my, what is my meaning of expertise in the subject? Now you can take the privilege of understanding this trick also. Okay. Number of tricks you can apply. This is one type of trick you can apply so that you will not get any doubt. Okay. So this completes my 3 concepts. Okay. Abhishek, now I think you are comfortable with this concept. You should not get any doubt in the future analysis. Okay. This is the privilege I am giving for you to understand these tricks. Great. With this, I think the total story is completed. So negative feedback, positive feedback, who has listened my class, nobody will get a doubt to solve this type of questions. Okay. So can I move to the concept number 4? I'm going for the concept number 4. Okay. Great to see this concept. Let us move to the topic number 4 now. Topic number 4 is related to a differential amplifier concept. Differential amplifier concept. You see this circuit properly, which is one of the important concepts in op amps. Differential amplifier means both sides you see the input. And amplifier means it works with only negative feedback. You have only negative feedback here. Nothing to confuse. Okay. And one thing, a beautiness I'm observing in this amplifier, how it is looking, you can see. This amplifier, if you write properly, the design looks like this. Minus, plus, this is your output. It's looking, the system is looking like this. This is R2. If I take this as R1, and this as some Vx. And positive side, we have some resistor. This is R1, this is R2, and this is Vy. Perfectly, if you see this circuit, I can prepare in a correct way of representation. You can see negative feedback, negative circuit I have taken the top, positive I have taken the bottom. This circuit looks like this. Okay, a correct representation I made. Okay, great. So let's see how this question can be tackled. A student who is appearing for the GATE exams, he should not solve this problem. If you solve also, it takes some time to solve because superposition theorem wise we generally solve this type of problems. By taking first Vx consideration, inverting gain wise we'll solve, non-inverting wise we'll solve. Next step, we'll get the total output. Why you are wasting the time like that? There is a privilege he has given here, equal resistor balancing technique. In a differential amplifier, whenever you see equal resistors like this, okay, the formula is directly you can hit. It is R2 by R1, which is the gain, into Vy minus Vx. Who will have the straightforward tricks like this in a standard formulas, standard circuits? It is easy to make the time. Okay, you will be benefited with time in the GATE exams. If you solve like a common student this type of questions, I think it takes a lot of time to solve it. Okay, can I expect this question in my class also have been explained? This is a CMRR equal to infinite circuit. Common mode rejection will be infinite for this. How, sir? Means if you give common input here, the output will be 0. So that is called Vy minus Vx concept. Vy is non-inverting side, Vx is inverting side. Vy minus Vx. If you know that simple formula, with the help of that, what he is asking, you can see, determine the required value of Vy. He is asking this answer. Find out the Vy such that the op amp should work in linear region. And other input he has given 3 volts. This side answer is 3 volts. This side answer is unknown. And he has given the saturation limits is 15 and minus 15. And he said that find out Vy such that Vy range, whatever you take, the op amp should not go to non-linear region. It should be in linear region. What do you mean by linear and what do you mean by non-linear here is, we have a op amp graph like this. This is V0 and Vd. We have transfer characteristic graph, correct? Op amp transfer characteristic graph, everybody knows. If you see the rough graph, it will looks like this, something in this manner. This is an op-amp graph. There will be some plus 15 here. This will be minus 15. This portion we consider as a linear. Above this portion we consider as non-linear. This portion is non-linear. We don't want to go above plus 15. I don't want to go below minus 15. How much is the input we have to apply is asking the question. This is linear region. This is linear. This is non-linear. You should not go beyond the non-linear. It should be in linear, he is asking. So can I write the condition? Can I write the condition? Your output should not cross minus 15 and 15. This is the condition I got for the output. Your output should not move above 15, below 15. Then you will be in linear region analysis. Correct? So with this concept, now you can start finding the range. How to find the Vy ranges? According to this formula, Vy can be written as V0 into R1 by R2 plus Vx. So this formula you rearrange and get the Vy first. Okay? Now, if I want Vy minimum, if I want minimum range, then we have to take output minimum range, output minimum into R1 by R2 plus Vx. This is the minimum range I am finding. What is V0 minimum is minus 15 is the minimum range. You cannot go beyond that. So the answer is minus 15 into R1. R1 is 1K, R2 is 5K. So 1K by 5K plus Vx is 3. So it is 3. Answer is 0. So Vy minimum range is 0 we are getting. Okay. So Swati Gupta 0 to 6. Great. This is a very good question. Conceptually they can ask you this type of questions. At that time output you have to take the range minus 15 to plus 15. You find two answers like this. Another answer is Vy maximum. If you want the range, it will be V0 maximum into R1 by R2 plus Vx. You can find this answer also. Okay. V0 maximum here is 15. 15 into 1K by 1K by how much? 5K plus 3. This is 5. Sorry. This is 3. 3 plus 3. We are getting 6 volts. So finally, in the options, they may give the ranges 0 to 3, 0 to 5, 0 to 6 like that in the GATE exams. So the well answer, most of the people has given good answer. Because has given minus 18 to 12. Friend, how you got minus 18 to 12, my friend? And Maiti is also 7.2. How you got these answers? I can't expect, my friends. See this is the procedure we have to do. Okay. Outputs cannot be taken above, below the values. Plus 15, minus 15. You can solve this type of problems. So the answer will be 0 to Vy is less than 6. So this is the beautiness of differential type of problems. I think this type of question I have not expected till now. This type of questions can be asked in future in GATE exams. Okay, be careful with the conceptual thinking. Whenever he said that it should be in linear region, your output information is ready. That is, it can be range between minus 15 to plus 15. Okay, now it's clear. Sahu, great. Great to see your answers. Very good. Wonderful. With this, I'm stopping the concepts of op-amps. Op-amps is closed now. We'll enter into the concept of oscillators in the next concept. We're entering for oscillators now. Okay? Yeah, Abhishek, thank you very much. We'll go for next concept, oscillators. Next concept, oscillators. Can you see this circuit? I have prepared in an irregular manner, but this circuit, my students, I think, have been studied in my class. Can you recognize what type of oscillator it is? I'll just give overview what type of oscillators we have, just recollection. RC phase shift oscillator is there. We have Wien bridge oscillator is there. And we have Hartley, we have Colpitts, we have Clap oscillator. And we have studied a stable multivibrator, which is a square wave generator. Triangular wave generator we have studied, and sawtooth waveform. So many things I have explained. Can you recognize what type of oscillator I created? accurate in a different manner. This is the way how this GATE exams will be. Generally, you know the circuit, but they'll give irregularly the design. Who will identify this circuit name? I think the story will be easy to complete. He's asking simply calculate the time period across the capacitor C. But the student has to identify what type of oscillator it is. Anybody? Can you give in the chat box? It's a very well-known oscillator. Accurate in irregular manner. You have to keep in a proper manner that circuit. You'll identify the best point of this circuit. What is this circuit? Ravi Kanta, Wien bridge is wrong answer, my friend. In Wien bridge, have you seen that? In Wien bridge, we need a Wien bridge circuit. Wien bridge means what? R1, R2, C2, R1, C1. There should be a bridge network. There is no bridge here. We don't have any Wien bridge. Wien bridge, how it looks? One resistor, one capacitor will be in series. One resistor, one capacitor will be in parallel. We don't have that. Only one resistor in series, one capacitor in parallel. This is not a Wien bridge, my friend. Anybody? Perfect. Maiti has given a good answer to me. Maiti and Verma, very good. I'm so happy for that. And Dev has given a good answer. And 465 AR has said a stable multivibrator. Perfect. Great. Simha is also telling a stable multivibrator. Perfect, my friends. Good answer. This is an stable multivibrator, which is a very, very important topic. Every year in the GATE exam, they're asking you. In a different style, they're asking. You have to identify it in proper manner. See how I designed it, this circuit. This is an stable multivibrator. You have to recognize it. Perfectly, if you see this circuit, I can write in a proper manner like this also. There is no worries. This is negative, this is positive. Okay, this is an output of the op-amp. We have some Rx. And we have some Rx. It's a positive feedback. And we have some resistor R. And we have some capacitor C. This is your VC. Can you see? Now, at least you have to recognize. It's a stable multivibrator technique. This is VC voltage. This is your op-amp voltage. In place of writing this concept here, I brought here to confuse the student. Nothing more than that. It's a very well-known circuit. Most of the times you have seen your GATE exams. It's a stable multivibrator, my friends. Okay, he's asking just the time period across the capacitor. First, you have to confirm the time period across the capacitor will be same as the output voltage across the capacitor, output voltage across the op-amp. You know the style of getting the oscillations. This is an stable, is a very well-known circuit. A stable multi-technique. Multivibrator. Everybody knows that it can also be called as a free running oscillator. Free running. It's a free running oscillator. A stable multivibrator, another name is a free running oscillator. How it is going to oscillate here is, it's going to oscillate like this, capacitor. This is a free running oscillations. From where to where these oscillations will be bounded is, one is minus beta V saturation by Smith trigger concept. We have two triggers for the stable. One is minus beta V set, one is plus beta V set. This only we call in op-amps as, great. This only we call it as UTP and LTP points. Upper trigger point, lower trigger point by using Smith trigger basics. So this is minus beta V set, this is plus beta V set. Correct? If these two we have the output across this. You have the square wave coming like this. This is your square wave output, which is plus V saturation to minus V saturation. So the output response is a square wave, and the capacitor response is like a charging discharging in the waveform. But have you seen that the time period of the output and time period of the capacitor is same? So that is my confirmation. So the time period of VC voltage is same as the time period across output. I confirmed it of V0. So we already studied this circuit, well-known circuit. We should not do formulas, all these calculations. The type of stupid things we should not do. Straightforward formula you must have. Swati Gupta already given the formula. That's nice. Great. Yes, great. You have given a good answer. And Rama is given 2RC ln of 3. Perfect answer. Great. Good answers. The answer is here 2RC ln of 1 plus beta by 1 minus beta. If you don't remember this formula, at least now you practice the formula, so that it saves a lot of time to solve this type of questions in GATE exams. It is 2RC ln of 1 plus beta by 1 minus beta. Beta is nothing but a feedback factor from the circuit. Your beta is nothing but voltage division rule, Rx by Rx plus Rx, which is equals to 1 by 2. Beta is coming here, a feedback fraction is 1 by 2 we are getting. So this 1 by 2, if you keep here, it is 2RC ln of 1 plus 1 by 2 by 1 minus 1 by 2, which is equal to 2RC ln of 3. In the exam, they'll try to ask you this type of questions. One thing a student should learn, in GATE exams, most of the times, calculation part, they will not take much. That's why I am also not interested when I'm teaching GATE type of level questions. Calculation part, I'll reduce. Only thinking and trick-based questions are very, very important for the GATE exams. Okay, calculation part, they will not give much. Only calculation part generally will come for ESE questions that are also very simple questions. They don't have much level to answer it. They are the straightforward theoretical questions. But in GATE level, they'll give a beautiful calculations like this. So I'm expecting this question is perfect. Everybody understood the style of doing the problem. This is a stable multivibrator, how I designed for the student to confuse this type of question may come in the future exams. Now let us move to one more type of oscillator. Okay, 2 examples I have taken for oscillation techniques. This is one type of analysis. So can I move to the next one? We'll see the one more type of oscillator. Okay, one more type of oscillator. Can you see this circuit now? Everybody will answer, I'm expecting. Can you feel what type of oscillator it is? Maybe I have used Mosfet here. What type of oscillator it is? Dear friends, I'm seeing your chat box. Everybody will answer this. My student definitely will answer this question. What type of oscillator it is? Can I feel that it's a very popular oscillator? Very good. Ravi has said RC phase shift. Perfect. This is a RC phase shift oscillator, correct? By seeing this network only, everybody can understand it's a RC phase shift network. This is a RC phase shift circuit. Sometimes in the exams they may give with op amps, sometimes Mosfet, sometimes BJT. I created with Mosfet how the style of question can be asked in future exams. In this total circuit, I have not given any data in the problem. I have not given any data. R is not known, C is not known, but question I have framed. What is the question here is, calculate the value of RD he is asking, which is a drain resistance he want in the given circuit where GM he has given for the Mosfet. GM is nothing but transconductance, 29 millisiemens. And lambda is 0. Lambda is 0 means everybody knows channel length effect is 0. If channel length effect is not there, lambda is 0 means R0 will not be taken into consideration, which is the output resistance of the Mosfet will be 0. Okay, sorry, output resistance will be infinite. This is the story. So lambda story here is your RD is equal to 1 by lambda times IDQ. This is your output drain resistance, which is an internal drain resistance. Mosfet internal drain resistance formula is 1 by lambda times IDQ. Lambda is the channel length effect. He has given 0 here. Okay, 0 he has given. If it is 0, can I say that it is infinite? Perfect. So RD is not required to take in the problem. And he said that find the value of RD. Can you see that this circuit is looking like an amplifier, A block, which is it is a common source amplifier. It's a common source amplifier, you can recollect. And it's a bypass system. These are all things we have studied in our classroom. These tricks we all know. It's a bypass, this is a common source. I never made AC models in my classroom. Shortcut tricks are very important for analog to do problems very well. Already a lot of students, I'm expecting they have given answer also. That's great. That's great to see your answers. Perfect. Can I see it's a common source bypass amplifier? The gain formula is minus GM times RD parallel to small rd. Actually, this is the standard formula for bypass systems. Minus GM into RD parallel to RD. But RD became infinite. So the answer became minus GM into RD. The only knowledge a student should have, the gain for RC phase shift you have to recollect. The gain for RC phase shift will be minus 29 for RC phase shift circuit. I already said in the course when I am teaching in the classroom, these values are very important to recollect because examiner will not give these values. If I ask you Wien bridge oscillator, what is the gain? It should be 3. If it's RC phase shift oscillator, how much? It's minus 29. So this is the trick. Okay? Great. It's a CS amplifier. Great. Perfect. AV is minus 29 and we have minus 29 millisiemens into RD. RD will be equal to 1 kilo ohm. You can see how I have set the question. Actually, I know already the answer will come minus 29. This way of calculation will be given by IITians. Okay? So the style of giving questions are very easy actually. But the trick you have to get spark in the exam. Who will get that spark means if he has a good knowledge of each and every circuit, if you concentrate well, definitely these gate questions are nothing for you. It's a fingertips to do in the exam point of view. Okay? So with this friends, I am stopping the oscillator basics. Okay, this is the content I am giving for oscillators. Everybody knows oscillators requires only 2 basic things. One is A beta should be equal to 1. Okay, first condition is A beta should be equal to 1. That's why in RC phase shift, if the gain is minus 29, the beta factor they will design minus 1 by 29. This is beta factor, which is the attenuation factor reverse to the gain. We are going to design it. And the second criteria is the total loop phase should be 0 degrees or 2 pi. This concept is very clear for me. In the first topic itself, I told you, whenever the total loop phase comes 180 degrees, it will become a negative feedback. If the total phase, whatever you are checking, if it comes 0 degrees or 360 degrees, we can say positive feedback. So oscillator requires a positive feedback technique. So if common source is giving 180 degrees, your RC phase shift also has to give 180. We are preparing some 180 plus 180, it becomes 360. So the bridge is balanced. Sorry, the phase is getting balanced. So it is a positive feedback system. These 2 criteria are very important for designing the oscillator. This is called as Barkhausen Criteria. This is called Barkhausen Criteria. Like this, questions can be framed in the exam point of view. Okay? So very good. Great to see. Bunny. Okay, Pradeep. Swati Gupta. Very good. 465 here. Very good. Barkhausen criteria. Nice to see to complete oscillators now. I'm going for the next interesting technique called topology technique. I'll take an example to understand the topology analysis. Okay. Next situation is topology. You can see one typical circuit I prepared. Let us understand we'll revise the topology technique. By seeing this diagram, can you feel what type of topology? You can tell with any name, because here indirect names I've given the options. Whatever you like, you can tell. Voltage series, voltage shunt, like that also you can tell. Series voltage, current, like that, whatever you like. Okay, but finally you have to catch what type of feedback system it is. Anybody? Can you see directly? Can you confirm what type of topology it is? Okay, in the chat box you can start writing the answers. Topology means only 2 things you have to verify. Output sampling you have to concentrate. Input mixing you have to concentrate. 2 things. Hit the circuit, you will get the answer. They will not take much time. So if you see here, this is the output, correct? Where you have taken the output, clearly you can see. You have taken from output voltage, not from the current. Current, if you want, what I'll do is, this point I'll take from here by taking some resistance to ground. I'll take the feedback from here. That means if the output V0 is here, on the other side if you take, we say current. Okay, the logic is opposite. Now wherever the voltage, if you take directly from there, it's very clear. You're taking here voltage sample directly. There is no confusion. Voltage sample we are taking. You're taking voltage sample. Okay. Pradeep, Meena, Urvashi, Ravi. Yeah. Ravi has given correct answer. Voltage series, my friend. Great. Swati Gupta, voltage series, great. But some students, Urvashi and Pradeep, you have given some wrong answer, my friend. We'll see where the mistake you have done. Let us try to understand it. Some students has given wrong answers. Mukherjee also given wrong answer. Okay. Why it is wrong? Please try to verify it. If you don't know, you try to start understanding the concept. This is voltage. It's very clear. Whenever there is a node, we call, or we can also call this as a shunt connection, we can call. This is shunt connection. So voltage can also be called here shunt connection. Voltage also we can call, otherwise you can write with the name shunt. Okay, leave that story. Come to here. What type of feedback it is? You know that RF is a shunt feedback, RE is a series feedback. The finally RF is connecting to your input, or RE is connecting to your input, means here RE is connecting to the input, means this resistor is becoming the feedback. Not RF is the feedback in this case, RE is the feedback, because RE is closing the loop. RE everybody knows in the subject, I have said so many times, this is a series feedback. RE always connect in series. So this is a series mixing, we can say. Series mixing. Like this you can understand the topology questions. Okay, series mixing. Suppose I am not interested in series, I want to make it shunt. This point you leave it off and connect to this point, to the base of the transistor. In place of connecting to emitter, you connect to the base. Automatically it will become shunt. The only thing is the positions. If you connect here, it's a voltage. If you connect here for this circuit, it's a current. If you connect this one to the emitter, it becomes series. If you connect this to the base, it will become shunt. It's very simple. Series, also call it as voltage source, because series always accepts voltage source. Now the student should know how to write the names properly. Let's see. First name, voltage series is the correct answer. Actually, this name most of the times we follow in our subject. Voltage series is the correct word I use generally most of the times, but examiner has not given like that. Voltage series means output is a voltage, input is a series. That means first voltage who is writing, he started the concept with a sample, and he has written the answer here mixing. This is the way you followed your terminology. First, whenever a person write voltage or current, you are starting output to input, the name you have been explained. Okay, this is the name you explained. Yeah, 465 AR, RF is feedback, no doubt about it. But that feedback is connecting to RE, which makes in series. Always in feedbacks, we have two techniques here. Shunt will be there, series will be there. Finally, which is connecting to the input, such feedback you have to take. Okay, both are feedbacks only, but in one series case, RE will become the feedback. For shunt case, RF will become the feedback. Please try to understand it. Okay, 465 AR. I think your rank is 465, I think. You have kept your name. Otherwise, your dream is 465 AR. I don't know. Okay? Very good. If you have a dream like that, that's a great. Already you got 465 AR, means very good. You are improving for the better rank. I'm expecting. Great. Nice. Can I expect voltage series? Voltage series, or we can also write it as voltage, keep it voltage only. Don't change that. Voltage, keep it voltage only. But mixing, he said that we can write series or voltage. So we can write this answer as voltage. Voltage is also correct. So sometimes in the exams, they can give voltage. Okay, these are two names. Sometimes I'm not interested in sampling mixing. I'm interested in mixing and sampling. If you start with series first, you are starting with mixing. And you are starting with sample at the final stage. Means you can reverse the name also. That means who will see first connection name, you are teaching from input to output now. But that name you can write indirectly as series. First you write series only. This is input. Series is series, don't touch that. But other side, you said voltage. If you want to write like a connection, voltage can be written as shunt. Voltage can be written as shunt. I think in this manner, he has given the option. So who is confused, please try to understand it. Very good. Which is feedback element? Then what will be the answer? Amit Pal, if they ask you which is the feedback element, there is no doubt. RE is the feedback. RF will not be the feedback. Okay? Always remember two feedbacks will be there, RF and RE. If RE becomes the feedback, it will become a series feedback technique. If RF becomes the feedback, it will become a shunt feedback. RE will be the feedback. Okay, Amit Pal, I'm expecting I have cleared your doubt. This is the feedback, not RF is the feedback. Please remember that. Okay, Amit Pal. So I'm expecting this is clear. One example is enough to understand the topologies, how we are going to predict the answers. With this, I have been completed successfully. Topology basics also cleared now. Okay, let us move to the next concept. Great. Okay, great to see these concepts. And we'll come to the next situation now. Okay, Rajput is telling crystal clear. Great, great here. So my work is going successful now. Very good. Next, seventh concept will apply. Seventh concept. Yeah, I entered into the very interesting topic called small signal theories now. You see some good questions. I have prepared two examples to complete small signal theory. Small signal analysis of BJT. Calculate the CAN in the given circuit. First, you see clearly these circuits are what? Whenever you see some cascading circuits, you should recollect what type of standard circuits they are. Can anybody give in the chat box what is this popular circuit? Very interesting circuit it is. Okay, very interesting circuit in analog electronics. Very good, clear, great. Great to see your messages, clear. Thank you very much. Can you tell what type of feedback it is? Well, sorry, what type of cascading circuit it is? Can you see that this is a common emitter? Everybody knows. It's a common emitter because base is input, output is collector. It's a common emitter. It's a horizontal where emitter is input, collector is output. It's a common base. So you're seeing here, the input here is base, the output here is collector, which is becoming a common emitter. I recollected. And here input is emitter, output is collector, base is common. So it's a common base. So in my classroom, most of the times I said it's a very wonderful circuit. Okay. Sujit Kumar, you should not say Darlington pair. Okay, Darlington scientist will get what I can say, he will get confused what he designed. It's not Darlington, my friend. Okay, I think you deleted that answer immediately. That scientist will get feeling about this. How can you say that is Darlington? Okay, CE and CB. Yeah, Rajput has said it's a cascode, sir. Very good. It's a cascode system. One of the best popular circuit in analog electronics. It's a wideband amplifier, we say. It will have a good gain and good bandwidth. It's a cascode system. Any two transistors you connect, we say cascade. But these circuits are well popular called cascode systems, which gives the gain and bandwidth at a time high. In general amplifiers, we get gain more, bandwidth will come less. If bandwidth is more, the gain will come less. But this is a peculiar circuit which will give both at a time. That's why it's a new technical name, cascode techniques. Okay? Everybody, I hope you understood. It's a cascode circuit. It's a cascode circuit. Okay. Have you seen that there is a CX here in the middle, which is a feedback now. This is a feedback. This is a feedback for the first transistor, Q1. Can I use some Miller's theorem or Miller's effect to find out what is CN without doing the complete approach? I am not interested in solving the complete circuit model. I just want CIN seeing this circuit. There are very interesting questions for the gate level. If I want to solve CIN, I need this CX how much the impact will come at the input by using Miller's theorem. Everybody knows Miller's theorem. I think Miller's effect. If you apply, we have a formula here. Z1 will be equal to Z by 1 minus AV. Here AV is nothing but AV1. The first transistor gain we have to take. Yeah, Rajput, thank you very much. Thank you very much, my dear. Lovely. Great. Very nice. Good. Correct answers you are giving. Z1 is Z by 1 minus AV1. Means first transistor gain I want, second transistor gain I don't want, because the feedback is going in the first circuit. What is Z1 here is 1 by J omega, okay, Cx1 will take, input side Cx1 will take, which is equals to 1 by J omega Cx into 1 minus AV1. Just formula wise I am applying the formula. We are creating the formula with respect to capacitance. J omega is cancelled. Cx1 will become Cx into 1 minus AV1. So Cx1 is the CAN only. You are finding the input capacitance. So the formula is created. Cx into 1 minus AV is the correct answer. But here most of the students will do mistake. That mistake, please don't do it. What is that mistake is? AV1 we have to solve in the class now. We don't want the overall gain. We want only first transistor gain. AV1, the formula is minus GM times into load. The formula is very simple. Common emitter gain minus GM into load. But I have seen that this is the load for my transistor. This is the load. For common emitter, the load is not connected with passive resistor. It's connected with the transistor. We call this as active load transistors. When a transistor is connected to a transistor, this will become, for common emitter, this transistor will become a load. And a common base input impedance, which is here, that will become the load for your transistor. Everybody should learn a simple logic. The input impedance of a common base is simple, 1 by GM. A common base will give always low input impedance. Most of the students knows that. It's 1 by GM is the correct answer for it. If it's 1 by GM is your input impedance of the common base, that will become the input, that will become the load of your common emitter. Perfect. It will become the common emitter. So can write here minus GM into load becomes 1 by GM. Answer is minus 1. AV1 is getting for a cascade system minus 1, my friend. If AV1 is minus 1, substitute here the answer. CIN will become Cx into 1 minus of minus 1. So answer will become 2 into Cx. Perfect. So this is the way how easily we can solve this type of small signal theory problems. I think here we have used a technique called Miller's theorem effects. Miller's theorem most of the times we use in analog electronics. Try to have a grip on that concepts. Okay? Most of the students may do mistake on this. They may take not the AV1, they may take the overall gain. The answer will be different. Here actually Cx is connected to the first transistor. We don't want the complete circuit. Only AV1 we have to solve. In that also the student should have a trick that the second transistor is a load for the first one. The second transistor input impedance is a load for me. That's why that load we call it as active load we call, not the passive load. We call it as active load. So I'm expecting you got the answers. Very good. Nice. Very good. Great. You got the good answers. Wonderful to see these answers. Let us move to the next question. One more question we'll see to complete this task. This type of questions may expect in GATE exams. Let's see how to solve by using small signal theory this question. Okay. You see here they have given a transistor. They have given some RB in series to ground. Here R Thevenin is asking. This type of questions are very interesting to solve this type of problems. I'll take an example how simple I can solve this type of questions. The only thing is small signal model we have to write for this. Everybody knows there is a here R pi will be there. There is R pi. This is R pi in the model. And there is some current source here. GM into V pi. So small signal model means nothing is there. These two we have to replace with the transistor. R pi is an input impedance of a common what I can say BJT input impedance for a common emitter, and GM into V pi is a current source. If you write this model properly, we can finish the problem. This is RB, and we have R pi, and we have a current source GM into V pi, and this is grounded. Here we want to find out the R Thevenin. RB, R pi, here we have the Thevenin find out, GM into V pi and ground. Like this, who will have a clarity? These questions you can do it very easily. Okay, so how I'll finish this answer within 2-3 steps. You can see this will take here some testing voltage Vx, and we'll take this answer as Ix. We'll find out the R Thevenin seeing from here is Vx by Ix. We'll take a testing voltage there. Okay, we'll apply only 2 steps to finish this answer. One step is, suppose if you have a point here A, we'll apply KCL in this loop. Can I say that this is V pi, so that the current flowing here is V pi by R pi. This is your base current, V pi by R pi. This side, one side V pi by R pi is the base current flowing. This side IC current is flowing. This side testing current is flowing. All the currents are going to the A node. We'll apply a KCL at A point. Okay, just solve the KCL here. V pi by R pi plus GM into V pi plus Ix will be equal to 0. Here all the currents are entering to a node A. All the currents entering is equal to 0 because leaving current is not there here. Okay, so we can find some relation between these two. Ix is equal to minus V pi into 1 by R pi plus GM. So a small relation I found between Ix and minus V pi. But we want the relation between Vx to Ix. What I do is one more. Can we apply KVL here? If you apply KVL. So if you apply KVL at input loop, can you see that this total voltage drop should be equal to 0. That is V pi by R pi into RB plus R pi plus Vx should be equal to 0. KVL is also simple. These two should be equal to 0. Correct? Great. So let us understand these two relation. We'll find out again a relation for this with Vx to V pi. Your Vx, can I write it as minus V pi divided by R pi into RB plus R pi. Perfect. So I have seen that I have found with one KVL and KCL I have used the efforts to get Is in terms of V pi, Vx in terms of V pi. So we'll take the ratio and cancel the V pi. We'll get the answer. Correct? So it's a simple way of doing these problems. So answer is minus V pi by R pi into RB plus R pi. This is Vx divided by Ix. Ix is minus V pi into 1 by R pi plus GM. So can you feel that V pi is cancelled, minus is cancelled. Great. Good. Then what can happen here is, if you take an LCM here, it is RB plus R pi divided by, here LCM 1 plus GM into R pi by R pi. Okay, this is R pi. So R pi will be cancelled. A student should know what is the meaning of GM into R pi. This type of basics we have to learn here perfectly. GM into R pi, what is the meaning of that is, R pi can also be called as 1 plus beta times of small re. Small re into GM, if you product it, it will become 1. So this answer is GM into 1 plus beta times of small re. Small re, GM are inversely proportional to each other. GM is nothing but 1 by Re. So Re will be cancelled. So 1 plus beta is remaining. So the answer is RB by 1 plus beta plus it is small re. Can you see this? This is the answer for it. Because here r pi by 1 plus beta will become again small re. So in the exam point of view, this type of questions hardly takes a concept of KVL and KCL. In small signal theories, we can do nicely like this. Okay, you have to take one KVL and KCL to get this type of questions. So maybe in future, in gate level, you can expect this type of questions. Don't get worried. In the exam, you just write the model clearly, apply the testing where you want, and finish the networks wise. You can solve the problems. This is a beautiful question in small signal theory analysis. Some students may confuse here. The answer you can write R Thevenin as it is 1 by GM also you can write plus RB by 1 plus beta. Some students has given the answer 1 by GM parallel they have given. That is wrong answer. It is not parallel. It will come series here. And RB is a quantity followed by 1 plus beta times, because small re whenever you write, on the other side you should not write RP. Because small re is the resistance at emitter side. You should balance the concept. If you write small re, RB has to fall by 1 plus beta times. That's a shortcut trick also. Easily you can write the answer straightforward if you have good basics on the modeling. This much calculation is not required to solve. Okay. So with this, I'm stopping the analysis of small signal theory of BJT. Next, we are moving to the final two topics to end up today's class. Hardly 10 to 15 to 20 minutes will finish the total story. We have covered the good models, so this will be a good boost up for the student who is going for the GATE exam. This content will be a good booster for the student. Okay, great to see your messages. I'm very happy. Great. Thank you very much for giving good comments. And we'll see the next one. Next one, small signal theory of Mosfets. I have taken two examples for this also. We have some recap about the Mosfets also. Can you see the question clearly? Estimate the voltage gain. Most of the times in GATE exams, they'll ask voltage gain problems. In the previous questions, you have seen voltage gain problems. I'm not interested in calculation style, so I created like a formula concepts. Can you see the question? Can you see the answers? Straightforward, can you pick up the answer? If you have the talent, you pick up the answer straightforward. Already my students, I think you have the ability to answer this. You have the tricks, because in the classroom, I never explain model techniques. By seeing the diagram, how to apply the trick of the formula is very important. Can you see some common sense in the question? From all the four answers, what is the correct answer is asking. And he said that here, lambda is not equal to 0. That is one important point. Lambda is not equal to 0. That means channel length modulation effect he considered. When channel length modulation is considered, you know that R0 will come into the play role. Small R0. Because you know the formula R0, I said that it is 1 by lambda times of IDQ. So we have to consider R0 in the formula. This is a common sense point, first point. This is a very simple common sense point for the student when he is learning this type of questions. Okay. So 465 AR, you done mistake, my friend. Minus GM into RD is wrong answer. Okay. That only I'm telling you. Whenever lambda is not equal to 0 given in the problem, please don't write. This answer will be wrong. RD parallel to RL you have taken, but R0 is missing. That is wrong answer. This is also wrong. RL is missing, R0 is missing. Have seen this is the correct answer. Minus GM into RD parallel to RL parallel to R0. Because the formula is minus GM into load. Load is here. RD is also load. RL is also load. And you will get R0 inside also load. 3 loads will be there. But here, the important twist in the concept is, yeah, Rajput, B is, you said, my student, but clarity see the question one time. Some trick I have applied, some extra trick. Everybody is giving B answers. B answer. That's why I have given this as a GATE question for you. Can anybody can see one small mistake you are doing in the problem that I have been explained in my classroom? Don't do that type of mistake. Some mistake you are doing. I'm not accepting B is the answer. I'm not accepting this answer. Anybody? Why this answer is wrong? Any mistake is going in the problem? B is not a good answer. I am not satisfied with that answer. I am not satisfied with that answer. Yeah, very good. Agarwal said that the input resistance is there. Perfect. R should not be there in B. Good. Series resistance, very good. Agarwal, very good. Very good. You have been identified the trick. Here, there is R signal is given, my friend. Whenever R signal is given, AVS is not equal to AV. This only I explained in my classroom. Okay, like this they will twist your concepts. Voltage gain of your transistor will be same as circuit gain when R signal is missing. If R signal is considered, you cannot say this answer. You will get some extra concept. What is that extra concept is? We have some extra model here, that is V signal. We have R signal. And we have some ZI. This is VI. So we have to find some extra attenuation that you are missing in the problem. I hope now you understood it. No Miller's effect, Agarwal. Miller's effect is not required. AVS will be AV times into ZI by ZI plus R signal is the answer. This is an extra attenuation we are finding. Is only the gain of your MOSFET. Okay, so AV is already there, this answer, which we can write it as minus GM RD parallel to RL parallel to R0. This is your gain. Good. Don't use Miller's effect here, Robin. Here Miller's effect, why to use? There is no feedback. Miller's effect is not required. Here attenuation factor we have to find. And can you see the input impedance of the MOSFET is nothing but R1 parallel to R2, because inside there is a open. Open with R1 parallel to R2 is, this answer will be RG divided by ZI becomes RG. RG is a combination of these two resistors, voltage division rule, parallel combination is RG. RG divided by RG plus R signal. So I think he has not given this option. So I'm going for D is the correct answer. So a small concept, logic you have missed. So that type of creativity or that type of concentration you have to build up more. Okay. If they give happily this is not there, this is a simple question. If they give R signal, you have to understand the gain of the transistor MOSFET will not be same as the gain of the what I can say, the gain of your circuit. Okay. Now everybody understood this mistakes, please don't do it in the exams. Okay, it's a very important task which I have prepared for this concept. Okay, very fine, good, great. So D is the correct answer. Most of the students have said B. Now I think everybody got it. Mukesh Yadav got it, great. Swati Gupta, nice. Good question, sir, great. There are all the questions I kept in my mind where the students will do repetitively that problems, mistakes. That only I designed it. Okay, I have not seen any textbooks to design these questions. Just roughly I have created some questions where the mistakes will be going on. Okay, that is the concepts. Anyway, great. Let's see one more question to end up this topic. Next question. You see this question, which is a very peculiar question actually. Given by some telegram, I have seen one student has given this question. So I want to analyze this question for every student now. Where they will stuck actually. This question has given some data he has given. What is the data and what is the model? What he want to do? Let us understand it. Everybody knows small signal models. Small signal model is not a big issue to write. What is that? Here it is open. Gate to source will be open. Here we'll get some current source. Current source GM into VGS, like BJT only. Input side in BJT class we write R pi. In MOSFET class we take open. And current source will be from drain to source is GM into VGS. Seeing the model, I'll write the model. You can see gate, source, this is VGS. There's a current source, GM into VGS, and there is some R here, okay, and gate to R one end he connected is asking here what is ZIN. You can see this diagram and that model presentation I made. One time who can understand the model clearly, doing the problem is not very tough. Actually is asking from the drain side, but drain is not here, here is drain. After that one resistor is connected in series to the current source. Okay, in the problem he is asking find lambda is 0 he said, so R0 is not required. Here R0 parallel will come actually, which is a MOSFET output internal resistance is not required because he said lambda is 0, therefore R0 will become infinite. So R0 you can neglect. So in this question can I expect he is asking ZIN is how much? Can I say that gate to drain, when you connect like this VGS only will come here, and if you take this current as some I0 VGS by some I0 is there, this is some small I0 will take, this is some I0, so we have to find this answer. VGS by I0 is ZIN there. Can you see one trick here? When you are sending this current cannot go this side because it's open. Gate to source is open, we cannot send the current to the gate. But the same current, this current will go to R I0, and this I0 will become GM into VGS. So concept is very simple. So finally the answer is very simple. It is VGS by GM into VGS. So answer is 1 by GM. So like that easily I finished the ZIN value. But here the target is how to find GM in the question. 1 by GM, great. 1 by GM is the answer, perfect. But 1 by GM, how to solve? For that they have given some sufficient data. Can you see here, your ID current he has given DC current 200 microamps, and he said the overdrive voltage is 300 millivolts. Please understand the data. If it is in current saturation, he said, so ID can be written as Kn into VGS minus VT whole square. This is a current saturation equation, everybody knows. Most of the times they will do these equations. It's a current saturation equation. Kn into 1 minus VGS minus VT whole square. We can also write ID as Kn into VGS minus VT is overdrive voltage square. VGS minus VT we can call it as VOV, which is called overdrive voltage for the MOSFET. Great. So VOV he has given overdrive voltage is 300 millivolts, which is VGS minus VT, and Kn ID is there, where we have to find the Kn there. Kn is nothing but your transconductance parameter Kn. We have to finish off. So this answer is given how much? 200 microamps. This Kn we have to solve, and I think 300 millivolts square. You can finish the Kn there. With this you will get Kn value, correct? So after getting Kn, I think you can expect some value, Kn value. It is 2 by 900. If you do it 2 by 900, 2 by 900 is coming to be around 2.22 milliampere per volt square. This is the units for Kn. Okay, Kn value you got. Then GM we can find. Everybody knows GM formula is 2 times of Kn into VGS minus VT. How you got GM means this formula, if you differentiate with respect to VGS, it becomes 2 times of Kn into VGS minus VT is GM. GM is nothing but derivative of ID by derivative of VGS. Okay, finally you got this answer, which is 2 into 2.22 into overdrive voltage is VGS minus VT, which is 300 millivolts. 300 millivolts. So finally you can solve this answer. 300 into 2.22 into 2. It is 1332 we got. 1332 millisiemens. This is GM I got. So if you want to find 1 by GM, it will be 1 by 1332 millisiemens, which will be coming around 750 ohms something. So this is the way any typical problems we can solve with the basics. So I'm expecting this question. I hope you understood. There are certain twists in the problems. 1 by GM is not only the matter here. How to find GMs are important. This will help you to understand how the GMs we calculate in the circuits. GM generally will not come from AC analysis. They'll come from DC analysis actually. Okay? They'll come from DC analysis. They always depends on DC analysis. So anyway, this completes the story of my MOSFET small signal theory questions. Last concept we are coming, where yesterday one student has requested me to teach this final concept, which is called active load concept. Okay, why to feel difficult and active load? A simple trick it is. I'll finish off with that. We'll end up the class today. So before going to this concept, active load questions, first you have to see these 4 models which I teach in my classes, trick questions. If you see active load 1, where you are seeing here means from the drain we are seeing. If anybody see from the drain, how to write this transistor like a resistance, equivalent resistance, is very simple. It will become R0. From the drain when you see, the answer will be R0. These formulas you have to practice to finish the problems very easily. Drain side when you see, R0 will come. Next question, model 2, when you see not from the drain, you are seeing from the source, suppose. You are not seeing from the drain, you are seeing from the source. The answer is very simple. It is 1 by GM will be the answer. It is 1 by GM. Okay. When you see diode connected transistors like this, that answer is also same as 1 by GM. So that is the reason these questions are very easy for me to finish off. Only these 4 models may come in your problems, active load problems. This load when you connect in your amplifier circuit, if you are seeing from the drain, change the transistor like a resistance as R0. In other 3 cases, if it is diode connector styles or if it is a source side, you have to write 1 by GM. Because source side, the impedance is very less, 1 by GM. Drain side, it will be high resistance called R0. These 4 tricks who understood, I think doing the questions are nothing. Okay. I have taken 2 examples for this. With that, today, I'll end up the class. Okay. Finally, 2 techniques. We'll finish the today class for you. So if you see this question clearly, calculate the voltage gain is asking. They have given some circuit like this. One thing you have to be clear your mind. Where is active load? You have to understand here. Which is my active load? This is my transistor with input signal means this is an amplifier. And there is a ground here. So this is load. Because loads can be represented above the transistor, below the transistor of your amplifier. Maybe this is called RD. This is called RS. Source resistance and drain resistance. Drain resistance is nothing he has given. No active load or no passive load. But here source side we have a load. So like this if you recognize this question is very simple. So where is my load is? Here is my load. Where the input is not connected, that is my load. This is your active load. And this place is RS is the place. In your amplifier, this is RS actually. That means if you write like an amplifier, this VIN, take like an amplifier concept. There is some RS will be there here. And this is VDD. This is your output. It's a basic amplifier circuits. The only your talent is, this RS is not passive, it's an active load. Then you already studied that. You're taking the output from source. You're seeing from the source. Then what is Rx value from the source is 1 by GM. That means this total transistor simply replaced by 1 by GM. So this will become 1 by GM. Completed. And what type of circuit it is? It has converted into a common drain amplifier. Because the output we have taken from source we have taken. It's a common drain amplifier. It's a common drain amplifier. For a common drain amplifier, the voltage gain is GM times of RS by 1 plus GM times of RS. A student should have this basic formulas so that quickly you can do it. It's a buffer actually. Same answer will come with 1 plus. Okay, if one is neglected, both will be cancelled. Your gain will be 1. So a common drain amplifier will give unity gain amplifier. And he said that M1, M2 have the same operating current. Anybody say that same operating current at same biasing conditions, GMs are same. That is the meaning here. GM will be same. So GM into 1 by GM by 1 plus GM into 1 by GM. So answer will be 1 by 1 plus 1. Answer is 1 by 2. Answer is 0.5. So like this, a single step, we can do the problems. Okay? Don't feel difficult. This is a very simple problems. You must know the 4 steps what I thought previously. That models we can apply it and finish off. One more example to clear off your doubt. Load is this one. I replace it by 1 by GM with my technique called source. Source side, when you see, you have to replace by 1 by GM. It became a common drain amplifier. Okay? 0.5 is the correct answer. We're coming to the final point, final topic. Great to complete within the time. Yeah. This question will be the final concept. I'll give just 30 seconds time for you. Can you finish this problem by yourself? So that I'll try to finish after 30 seconds. Where is your input? Where is your loads? Maybe loads can be 2, 3 loads. Any number of loads I can connect. Seeing the diagram, estimate that where is your loads? That loads, please replace it by using RDs, RS in your amplifier. If you see correctly, amplifier is in the middle. So this diagram is just looking like this actually. This is VIN. We have MOSFET. We have some RS here. Here we have some RD. This is VDD. And this is output. Your concentration should be like this. You should write a normal basic model seeing the diagram. Okay? This is one MOSFET. This is another MOSFET. Middle you have the amplifier. Amplifier by a side means signal you have given. Below is RS will be there. Above is RD will be there. Now your logic is what we have to substitute. At this point, we are seeing from the source, we are seeing source, whenever you see your RD will become 1 by GM. From the source, whenever you see your RD resistor can be replaced your active load as 1 by GM. In the same manner, when you see from the source again here, it is RD, RS is also becoming 1 by GM. So here also you are seeing from the source, here also we are seeing from the source. It may be diode connected or it may be like this, you will get same answer. So 1 by GM, 1 by GM. Both sides you got 1 by GM. This is also 1 by GM, active load is replaced. This is also 1 by GM, active load is replaced. Both is 1 by GM and 1 by GM. But this circuit, how it is looking? It is just looking like a common source unbypass amplifier, we can call this as. Correct? It's an unbypass common source because output you are taking from the drain, there is a RS value. If RS is 0, we can say it's a bypass. Now it is an unbypass. Unbypass formula, I think you must be able to know what is the formula of that to finish this answer. Unbypass formula is minus GM into RD divided by 1 plus GM into RS. Straightforward formulas. If you don't write this denominator, it's a bypass formula. Unbypass means you will get some extra factor 1 plus GM into RS, which you have seen in common drain amplifier. That is coming due to feedback here. RS will work as a series feedback in your electronics. That makes me to write that answer. Okay. So I think for this, how much the answer is coming is minus GM into 1 by GM divided by 1 plus GM into 1 by GM. So both RD and RS is same. So answer will be minus 1 by 1 plus 1. Answer will be minus 1 by 2. Answer will be minus 0.5. If you see clearly, this also giving the same answer, but with a negative sign. Okay. So I'm expecting today within the time, exactly 2 hours, 15 minutes, I have covered the entire most of the topics which are very typical for the student level. These topics who will practice well, I think you don't have confusion in your GATE exams. Mainly your professor, IIT professors will concentrate on these areas. So first get confident on these areas, what I taught today. Okay, if the video became fast, after the class also this video will be stored in your YouTube. You can watch today, tomorrow, whenever you want you can watch. Okay, finally please practice well. With this I'm stopping my lecture. My efforts I kept for you to learn some good concepts without getting confusion. So in future I think you will not do any mistakes. These are the good concepts I have taught for you. So anyway, today it is a privilege for me to teach all these things to you. Thank you very much for that. Nearly 2 months I got holidays. After that, this is the first day I started to teach the class. I'm very happy to see my students once again in the chat box. Really happy to see all these people. Great. So finally, one thing I want to motivate you. Please, the GATE exam may be postponed or may not be postponed. It is a war for us to do it. Okay? It may be in 5th. If the exam comes, we have to be ready. If the exam is postponed for 1 month also, we should be ready. So your mind should be on the focus of the target only. Don't think all these things. It can be postponed, it cannot be postponed. Maybe, God grace, tomorrow when you are getting lucky that suddenly you got a chance that tomorrow the holiday is not there. Sorry, the postponement came in the news, you will get. So nobody can expect it. You done your side. Okay, you kept some petitions. Most of the students have done it. Most of the teachers also encourage you to do that. Okay, different institutes has came forward and they have done it. But one thing please remember, you done your work, you leave it. Now you start doing your work. Because 5th, if it is the exam, your target should be on 5th only. If you have been prepared entirely for 5th, if the exam came on 15th, it is easy for you to practice. So don't focus on all these things. Within 10 days, this 10 days is the main target for you. So take less time for sleep for this 10 days. How much efforts you can keep, how much hard work you can do, you do it. And this 10 days mainly, don't do total notes practice, all these things. This 10 days should be only the work on concepts. Okay, revision on workbooks. These things we have to revise it. Okay, don't concepts you have studied already. All the pictures are over. Where the typical points are coming, where the concept I'm not getting, that concepts you build more. Unnecessarily don't waste the time in reading the notes number of times. Already you got a what I can say hobby to do the problems in all the subjects. In that manner you try to do it. Okay, so I believe that okay, in this pandemic situation also you're doing a lot of work. Okay, God will bless you, my children. Anything who will do sincerely the work, okay, they will get failure in life. Okay, as a teacher I also do every day the work. So who will stop the work? I think he is failure in his life. So doing hard work is very important. Okay, I'm very happy. Today I'm ending the class. Thank you for getting in the live. A good number of students came. So very happy to see all of you. Thank you very much. So who has missed the video, you can see number of times. Whenever you have time, you can send just forward this video to the friends also, so that they will be benefited with this one. Thank you very much, dear students. I'm leaving. Thank you. Thank you very much. Yeah, Vinesh, thank you. Great. Love you, my dear students. Always keep your efforts, okay? It may be success or failure, don't bother. Your efforts should be continuous. That's a good thing. Great. Kumari, thank you very much. Yeah, Robin, thank you. Maiti. I think today class concepts have been helped a lot, I'm expecting. Okay, whenever you have doubt, you can see the video. Okay. So anyway, I'm signing off. Thank you very much. Good night.